more when we get to that stage. Eventually, you'll be doing these proofs on your own. You'll be finding the statements and the reasonings on your own. You'll be able to do that. But right now, we're just doing fill in the blanks. So our proof on the left side is going to have these statements, and then we have to give reasons for those statements on the right side. And most of our blank spaces in these fill in the blank proofs are going to be the reasons. At the bottom of this worksheet 2.5, I put a word bank of all the properties that are going to be used in proofs so far. Properties, theorems, and postulates. So you can scroll down to the bottom of 2.5. I'm going to probably copy that over, put it into 2.6 so that you can access that word bank. On your Chapter 2 test, you will have a word bank to help you with those proofs as well, just so you know. So you're not going to have to just pull them out of thin air. We're going to give you a word bank, and you're going to put those in the correct spot. So how a proof is set up, you're going to be given some information. So you have to have something that they tell you to kind of get the ball rolling. Like, here, I know what's kind of happening. Now I got to start to figure out how to get to the end goal. The prove is the end goal. We got to prove that x is equal to 6. So somehow the unknown variable in there is 6. And we got to show how we can prove that. So we'll start looking at filling in the blank on this proof. The very first statement, C is the midpoint of AD, you'll probably notice is exactly the same as what they were giving to us. So when you do your first reason in a proof, that first reason is always going to be given. So you're going to give that first statement. You're going to just kind of repeat what was written up here. C is the midpoint of AD. That is my given information. And if you're using a hard copy and you want to make some notes, that's going to make those two segments equal. So that's going to be what happens when you have that midpoint. And that's exactly what the statement in problem 2 is saying. So problem 2 says AC, segment AC is congruent to CD. And if you look down at your word bank down there, that is because of the midpoint theorem. And midpoint, I always abbreviate it MDPT. And theorem, I always abbreviate THM. So the midpoint theorem tells us that if you have a midpoint, it's going to split your segment into two congruent pieces, which I marked with the tick marks. That's my reason. Next is all filled in for us. Number 3 says that the segment length of AC is going to equal the segment length of CD. You're probably wondering, well, what's the difference between these two? It still says AC, CD. When it doesn't have that symbol, we're now talking about the length. So the length of AC, whatever it is, we don't know what it is equal to CD because they're congruent. Our reasoning is congruent segments have equal length.
So it doesn't have to be out of the word bank for proof.
Sometimes you can just kind of give your own little definition. If you know something like, and the next one we're going to be possibly using that 90-degree angles are all congruent to each other. So if you have a 90-degree angle, it's going to be congruent to any other 90-degree angle without much other proof. So sometimes, yes, you can just give a little definition of something to prove your point. But I would say most of the time we are using out of that word bank. Problem 4, 4x equals 2x plus 12. So if you go back and look, 4x is the unknown of AC, 2x plus 12 is the unknown of CD. So what we're doing is we're taking AC out and we're replacing it with its unknown, 4x. We're taking CD out, we're replacing it with 2x plus 2. So what do we call that when we're replacing something? And you also do it if you're in sports. You go in, you replace somebody who's in the game. What do we call that? Sub. So if you look down below at your word bank, what property are we using? Substitution property. If you just put substitution, I'll know exactly what you're talking about. So that tells us that we've taken AC out and we replaced it with its unknown value, which is 4x. So we've used the substitution property. Next, it says we somehow used the subtraction property of equality. This is getting into algebra. We didn't do a ton of review on some of those algebra properties. But the subtraction property of equality says that you can subtract the same amount from both sides of an equation, and you're going to still have your equation be equal. So we want to figure out, well, what statement are we talking about? Well, looking at the algebra steps, if you have a 4x on this side and a 2x on this side, it's going to make logical sense. Let's get the 2x moved over. Well, if 2x is positive, what am I going to do to move it over to the other side? Subtract it. We subtract 2x on both sides. We're now left with 2x equals 12. So the 2x on this side cancels out. Subtract it over. 4x becomes 2x. Now I got 2x equals 12. And lastly, I somehow got x equals 6. So what did I do to both sides of my equation to get x equals 6? Divide. So you can just put the division property. And there we're done. There would be our proof finalized. So you're getting into those algebra steps. A lot of times we do algebra just second nature. Okay, I got to subtract this over, I got to add this over, I got to divide by this. Now we're just kind of slowing it down, and we're going to give a reason. Okay, here's what I did. I did the division property to get the x equal to 6, because 2x's equal 12. I'll divide that by 2. 1x is going to equal 6. So above, when you're working on numbers 1 and 2, you're going to do a lot of those algebra properties to explain your reasoning on how you're doing each step. And up above, I'll give you a hint too that you're going to be using distributive property. That's one that we didn't use on this one that you will see on number 1 and 2 if you haven't done those yet. Am I okay to erase this one? All right. Then we're going to look at our first kind of major geometric proof on today's worksheet, which is 2.6. And this is an 8-step proof that we're taking a look at. So I'll let you take a second, get that out. Got them all?
Yeah, I was going to go to hour 7.
Oh, and then could you put that test in too? Yeah, just put that, and if they're if I have put a little M, just put M and enter.
No, this is just how you change the section.
Yeah, you want
Then
you can do that. Perfect, thanks. All righty, here we go. You guys ready? 7-step proof. All right, so here's our goal. We want to complete the following proof by filling in the blanks. Given that angle 1 is congruent to angle 2, we want to prove that angle 3 right here is congruent to angle 4. And unfortunately, we can't just say, oh, they look like they're equal, so they must be equal. We can't just say they look like that. We have to actually prove it out. So I'm going to do some markings since I'm basically kind of using a hard copy. I'm going to mark that angle 1 right here is congruent to angle 2. So we'll put an arc on each of those. That's what our given information is. So our first statement, okay, we're given. Next, we look at the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5 is equal to 180. So I'm looking right in here. 3, 1, 5 are equaling this straight line right here, which is 180. So we have to give a reason why are those 3 angles adding up to 180 degrees. Excellent. I love the first thing, yes, supplementary, but I love your second. That's kind of just giving an explanation. Well, it could be supplementary, but it could be using the angle addition postulate, adding up to a straight line. And you could write that out if you wanted to, but I'm just going to say they are supplementary. So we're just going to use the definition of supplementary, which I'm just going to write supplementary for that. So 1, 3, and 5 are adding up to a straight line, which means they are supplementary. They're adding up to 180 degrees. Next, we look at, okay, measure of angle 1 plus measure of angle 3 plus 90 equals 180. Now look from this step to this step. This angle changed to 90. So we replaced the measure of angle 5 with 90. What did we use for that one? Substitution. Substitution. We took out, we used the box right here. This is 90 degrees. Okay, we replaced 5 with 90 degrees using substitution. Then we went back to measure of angle 1 plus the measure of angle 3 equals 90. Now I would accept a couple answers here. But if you look at the step above, we got rid of that 90, and then the 180 became 90. So what did we do to both sides of our equation?
What we did not.
We subtracted 90 from both sides. So 90 got subtracted from 90, canceled out on this side, 180 became 90. So I would accept, okay, you put subtraction property, that works. But also, what do we call two angles that add up to 90? Or, yeah, two angles that add up to 90. We could say complementary. All right, so I'm going to say subtraction property. But if you put complementary, you are okay. You'll notice that in geometry, it's a lot of creativity. What can I do to prove to get to this step, to this step, to this step? So we'll say the subtraction property. But you could also say that 1 and 3 are going to add up to 90 degrees. Okay. Now we're kind of leaving this on the back burner. We're going to start looking at other angles. 2 and 4, these two. So we've already now started to prove that 1 and 3 are going to add up to 90. That's kind of what our goal was here, is to prove that those add up to 90. Our goal over here now is starting to look at how angle 2 and 4, how they compare to 5. Before we get to that, I'm going to kind of try to highlight in green these two lines. This line right here, this line right here. And we're talking about this angle and this angle. I'll delete that in a second. So angle 5 compared to angle 2 and 4, we're trying to say that they are equal. But why would they be equal? Excellent. They are vertical angles. Nice. They are vertical because they form that X formation. It's kind of a T right now, but then they're opposite of each other. So 5 has to equal whatever 4 and 2 are because they are vertical angles. Perfect. You could say vertical angle theorem. I just always use vertical angles. Good to go. If you want to say vertical angle theorem, awesome, it'll work. Now again, measure of angle 4 and angle 2, you look from this step to this step. Measure of angle 5 became 90. So what do? We replace the measure of angle 5 with 90, which is substitution. Okay, we're getting somewhere. I'll be able to fit 7 in there, then 8 I'll probably put up over here because my thing is getting in the way. Now we got to start looking back to our previous step. So we've now taken the measure of angle 4 plus 2 is 90 because we got the 5 to be 90. Now we're saying the measure of angle 4 plus the measure of angle 1 equals 90. So measure of angle 2 became the measure of angle 1. Well, how can that be? Well, if we look back to this given statement, what's true about angle 1 and angle 2? They're equal. They're congruent. So if I take the measure of angle 2 and I replace it with the measure of angle 1, I can do that because they're congruent. They're the same. So we did another replacing. So what do we call that when we replace something? Substitution again. So now we've got the measure of angle 2 and the measure of angle 1 are equal. So I can put in the measure of angle 2 when I am talking about the measure of angle 1. That's fine. So the measure of angle 4 plus the measure of angle 1 is equal to 90. Now 8, I'm going to have to put up on the side over here. I'm just going to put it way up here. Now we're on to number 8. So looking at these looking at these two steps. So we've got to somehow compare 4 and 3. So I got to look at how 4 and 1 compare, and then I'm going to look at how 1 and 3 compare. Right here. So looking at this, measure of angle 4 plus the measure of angle 1 equals 90. The measure of angle 3 plus the measure of angle 1 equals 90. If I say that the measure of angle 4 plus the measure of angle 1 equals 90, also the measure of angle 3 plus the measure of angle 1 equals 90. There's a couple ways we could think about this one. Let's look at it this way. The measure of angle 1 plus the measure of angle 4. I wrote that too big. Let me write it smaller. I'm just going to use angles. So angle 4 plus angle 1 equals angle 3 plus angle 1. What could you do to both sides of that to make angle 4 equal to angle 3? Could use the subtraction properties. That would be something that we could use for this one. Now, we have to still give a step of what's happening from 7 to 8, or we're going to have to look back in our proof to kind of get that angle 1, angle 3 happening. Yep.
Wouldn't number 7 be transitive because you're not subtracting something, you're just like moving around?
Or
Number 7 wouldn't just be transitive?
from here to here be
Right,
transitive?
because it's not substituting, it's changing the angle from straight to one.
Well, I am using this up here that 1 and 2 are equal. So it wouldn't quite be transitive. So all I'm doing is substituting, saying that if angle 2 is equal to angle 1, I could put angle 1 in for angle 2 right there in that step. So we're going to say it's a substitution. But one thing you could do, if 8, you want to put subtraction property, you can go ahead, you can put the subtraction property. You subtracted 1 from both statements. But there is another theorem out there that says the complements to the same angle are congruent. So if you know that angle 4 and angle 1 are adding up to 90, and you know angle 3 and angle 1 are adding up to 90, angle 1 is the same in both of those. So whatever's left for angle 1 and these two angles to equal 90 has to be the same as well. And that one is a little bit more tricky. I like using the subtraction property. That's what I put in the answer key. So we could use subtraction property, or you could also use this congruent complements. And I'll be honest with you, we don't use that proof, that reason, congruent complements. We don't use that we don't use it at all throughout the year. This is the one problem that we see throughout the year that's going to be on. The subtraction property is one that you'll use definitely a ton more in our proofs. But you could say congruent complements in that problem.
Now, if we're using a problem, like in chapter 5 or something, we don't give a proof, well, that's entirely incorrect.
If we don't give what?
If we don't give a proof when it's required,
Oh, so
will they be like half credit?
so a proof like this. So this one, since it's fill in the blank, this is a 7-point problem. But if you have to make your own proof, this would be a 14-point problem because you get 1 point for the statement, 1 point for the reason as you go. So if you maybe miss just one part of your proof, you're maybe only getting 12 out of 14, or you're getting 10 out of 14 on that proof.
Okay.
So if you just did, but I'll be honest with you,